the email thread or string thread. It's the same thing. We can consider the series of instructions as a thread. Okay? Then, if you are using the very simple program, it has just one thread. But think about the microprocessor, Microsoft Word. So when I type something, my Microsoft Word program keeps checking the even syntax. And I type, this will get the input, also display, output. Different tasks. Sometimes they are independent. So checking the spelling is independent from the type. Okay? So they don't bother each other. So whenever I type, the spelling checker will check whether it's correct or not. So which means, can we learn the simultaneously? Okay? But if we have the processor, 2-core, multi-core, yes, we can separate. Even that's not easy. Okay? We need to communicate. However, simply make the different thread. However, we have suppose we have only one CPU, it can execute only one thread. However, if we create a different process, it requires what? Context switch every time. Whenever I type one character, so this spelling checker need to access. Why don't we combine the different thread into one program, but simplify such a context switch? Because it's the same program, they are accessing the same file, so same thing, almost the same, but a little bit different code. So instead of the context switch, actually context switch, as you can realize, it requires a lot of input and output. It's a slower. It makes it slower, your operating system. So this thread actually share most of the information. It's one program, but only different the sequence of the instructions. Right. So that is the idea of the thread. So for example, the Java use the concept of the thread when you create the process, right? Because it's under Java virtual machine. Java virtual machine is the process that you create when you execute it. Then inside the Java virtual machine, it will actually create the thread. It looks like the different process. So we will see details about the thread. The main purpose of the thread is speed up processing your process. Then I mentioned many times schedule. Pick up one process from here. Then how? That is a process scheduling. Okay. They operating system maintain the queues because anyway the scheduler will pick up the one process from the queue. There are different types of the queue. First one is a job queue. Job is the process. It's a task. So we have list of the job. So that is the job queue. And ready queue is on this only process this state. Okay? Ready queue. And device queue is, for example, during the I/O wait, so read the hard HED0. So this one will be accessed by the many processes. There are many requests. So each device should manage such a queue. Okay? So that is the device queue. So this is the example of the ready queue and with the many I/O device queue. For example, ready queue. You can see it has nothing but PCB. So linked list. So you don't have to create the queue. Queue has only the header and tail. Then it has a pointer to the PCB of the 7, is a process 7, whatever, and process 2, and the tail. You can manage the tail. This is a linked list. And similarly, we have this is a magnetic tape. There's nothing no process, and this is a disk 0. It has there are 3 requests from the processor 3, processor 14, processor 6. How can you manage? Using PC. You can just link the pointer address of this one, this one, this one. You can link to this. This is a terminal. Terminal means output device to display. So the processor 5 is using that terminal. Output of this one is displayed in this unit, something like that. So this is the overall representation of the processor scheduling. First, we have the ready queue. Okay, if from the ready queue to the CPU, it's a running queue. It's a running state. Then, during the running, there are different ways of the process. The first one is the most popular one is the I/O request. Then it will be I/O wait. Okay? And sometimes expire, then which means it's running, but there might be limitation of the CPU time. So it's expired, then going back automatically ready queue. And sometimes this process create another process. That's usual that we'll discuss near soon. That is a fork. At the time, the child process will be created, and both child that child process definitely go to the ready queue. Okay. And also in case of the interrupt, is interrupt. You need to wait. Go back to the ready queue. Otherwise, if done, it will be terminated. So this is the overview of the processor scheduling. Then there are 2 types of scheduling. First one is a short term. Short term means it frequently happen when you have. This is a CPU time. So we are going to share this one. Slice the time. Then this one is a processor 0. This one is process 1. This is a process 0. This is a process 2. Something like that. This is a short-term scheduler. Okay. Long-term scheduler means before this one, there is a scheduler to select the specific job, specific process. Okay. It's not frequently happen. Instead, for example, memory is a full of this is process 0, process 1. There's no more space. Then we'd like to bring this process 2 out. It's called the swap out to the hard disk drive. Then we have the free space. Then bring another process, swap in. At that time, to select one of the big 2 process, that is called long-term process. Is it frequently happen? No. If this one happen frequently, your system is very, very slow. However, this one, usually it's a millisecond. Otherwise, the overall performance of your system is very, very slow, low. Okay? So it's a frequently happen, like less than millisecond. That is a short-term scheduler, and that is a long-term scheduler. However, most of the scheduler that we are saying, the scheduler or CPU scheduler is a short-term scheduler. So nowadays, we are not using a lot such a long-term scheduler. Why? It's too risky. Okay? If you bring all the process out to the such a swap space, so it takes long time. As you can imagine, it require I/O on hard disk drive. So nowadays, instead of using such a swap in and out long-term scheduler, we can use page in, page out, which means we slice each program by page frame. So we will see such a page, the replacement later during the memory management. So mostly when we are saying the scheduler, that is a short-term scheduler. From the ready queue, we are going to select the process that will be executed on the CPU. At that time, idea of using such a scheduler is actually I/O bounded job and CPU bounded job, which means each process requires something input and output. That makes sense. Think about it. Without using any data, does it make sense to run the program? No. Definitely you need such a data. So it requires, which means the I/O. But some of the process need a lot of I/O input and output, which means you can actually set aside the CPU resource. So comparing to the number of I/O, the CPU amount is small. So at that time, we can get the benefit of such a scheduler. So some of the operating system use the medium term, which means it's a mixture of long-term scheduler and short-term scheduler. So for example, this part is a short-term scheduler. Okay, it's that we are going to discuss in detail. But sometimes if that is it's kind of the partial, it's kind of the page in and out can be considered as a kind of the midterm schedule. So we will see. Nowadays, the swap area is considered as the virtual memory. Okay. So current operating system does not actually swap in and out. Even though the name is swap space, it can be used for virtual memory, which means this area is considered as part of the memory. So we can just page by page, small size, it's usually 512 bytes in and out. So that can be considered as the medium term scheduler. So, scheduler. So mostly when we are saying the scheduler is a short-term scheduler, it's a very frequently happen, less than a millisecond. Okay. What about the mobile system? Like the iPhone or the Android phone? It's the same thing, okay, as we have seen, but it has more strict, okay, such as scheduling. It's a very limited. Why? It's a battery power. Because of battery power. For example, when you move such a state, it's a still running program, right? So even though we have only one CPU, so we have only one CPU time, but the other process are doing something like the input and output, or I/O wait, okay, and other job. So, however, the mobile device, like the cell phone, if you allow such a, it's called a background job, okay, so then it still consumes a lot of power. So old version of iOS actually allow only one process active. Even active does not mean only the CPU, but also it's a stop. Even I/O wait, so I/O and other, all the instructions are suspended. Okay, then only one process is the active to save the battery power. However, nowadays they allow some very limited the background as a service. So you can allow some notification by saying. So it's not a good idea. So when I visited, it's a surprise. So during the winter break, I visited China to teach a course in one of our sister university. Then many of the students, actually many of the people, they use the iPhone, even iPhone 6. But I surprised that most of the people keep the even bigger device. I didn't know what that is. Do you know? With the cell phone, and there's another device that is a battery. Some 2 or 3 times bigger than sometimes the iPhone 6 that they keep. So because of the battery power, and also the sister university actually limit the power after the midnight, and so students keep the extra device for battery. So Also, I learned that I'm not a big fan of the Apple device, but my daughter, she's using iPhone. She complains every time. So the battery power is going very well, like very quickly for the iPhone. I think that is because of she turned on most of the feature. So she turned on every feature, every notification, it consumes a lot. So please, the limit such a service, okay? But long time ago, even the iPhone did not allow the multiple process, but nowadays the limitedly allow such the background process as a service. However, that background a little bit different concept as the traditional background process, but we will discuss later. So we already talked about such a context switch. So change it. Context, the more context switch, the better? No, definitely not. So less context switch is better. So when we judge the performance of the operating system, we count sometimes how many context systems. Okay? In the process management, now you can think about the creating process, because that is the nature of the operating system. What happened when we turn on the system? There are multiple steps, but finally, kernel process will be started. That is the first process. So based on our discussion so far, the kernel process started. Then, what about the other processes? Are they started right away? Actually not. After this process, first process is created, then this process will create another child process. Sometimes one or more process. This is, for example, process ID 0 and 1, 2, 3. They are children of this one. So this is the nature of the modern operating system. They form a tree structure, which means process mostly created by another process. So how to create the process? We can use system call. So system call actually provides most of the function that you need in operating system. Okay, it's kind of API of your system. So we can use such a the system call in C, that is fork and exec. So in Unix example, and the Windows API, Windows use Microsoft to provide create process system call. Okay, if we are using the Windows API, they use the create process. But in Unix, it's well known fork and exec. When I joined the first company, the manager, supervisor, he after that, so I was not asked such a question because I was not selected by my supervisor. But from time to time, we had an interview for the new employee in the IT department. So most of the time, my supervisor asked this question: what is the difference between fork and exec? Anyone who knows? Probably you learned from the other class to create the process. You learned you need a fork and exec. So what other? Is there anyone who knows the difference between fork and exec? No? That is the reason we need to study today. Anyway, so because nowadays many of the application the program language they hide is a kind of abstraction level. Most of the developer may not realize using the such a fork and exec and what's going on when you use create process or the exec function. So fork is the system call to create the process, which means what is the creating process? Allocate the memory and copy instruction, but not yet because of this. So when you create the process, creating process, the first step is copy, make the clone of current process. If I create the process using the fork, which means copy myself, it's an executive copy. That makes sense. Think about mother and children, such a genetic. It's actually copy, right? No, it's almost copy. So it's a copy of the parent process to this. That is the fork. It has separate the memory space, like this one. Even share the code section. Instruction is the same because it's a copy, but it has a separate space, memory space. That is the fork. So once you submit the fork, it has the process ID, child process ID you can get as a return code. Okay, then EXEC is kind of a separation. I have my own characteristic. That's different from my parents, right? After EXEC, we can copy code for this child process. For example, this is corner, this is the for swap. When you fork, it's just copy, but when you EXEC this data part, text part, you can copy instruction for the swap. Okay? Then it will be separated. That is EXEC. Many of the students, many of the developer complain, why do we need to execute the two in the system code? That was the reason Microsoft API, they combine into this and this into create process. But exactly the same. Inside the create process, they are doing the same thing. First copy of the current process, then assign the this. So that is the reason. Sometimes system.exec. So you can run something, the ls or dir. You can run the command or you can run the program. That is called exec usually. Why? Because it copies the instruction separately like this. Okay? So that is fork and exec. I'm not sure whether you have an interview. This will be the question, but you better know. Then eventually it will be like the free structure. So what time is it now? Because the clock is broken. So a couple of 1 minute. Okay. So this is the this diagram shows the process creation. Okay. So it's based on fork and exec. The fork is the same as the just copy of the parent process, and when you submit the exec, then it will copy the children own the instruction. And however, it will be governed by the parent process. Okay, which means when I get back to home, I need to inform to my parents I'm back. Just like that. So you need to inform to your parent process. Always, always. However, there are some exception. Okay, we will discuss about such an exception on next class. So this is the last slide. This is a C program. More popular program. If you are doing any Unix program, you probably see this one. Okay, you can create a process using one simple line. Fork. That's it. Then, if you submit the exec, when you submit the exec, you need to specify the specific code. Like in this time, it's ls. This child process works for the list ls program. This instruction will be loaded into the child process, the text area. Before that, this PID is the same as the parent process. Parent process means this process, this program itself. Parent of this one is a shell program. Then you desktop program or the shell program, that is actually same process. When you double click this one, it will be create the same as the shell programming, then copy instruction of this one to the current process. Okay? This is an example of the Windows API. You can see we need one to create the process. The same thing, the programming. Thank you, and we will see Thursday, 8 o'clock, we will finish the other part.